Yeah, can you see my screen now?
Yes, I can see your screen.
Okay, now let's understand how the pressure is, calculated in the liquid column. Okay, H rho G basically we need to find out, and pressure is given as H rho G. There is height, density, and the acceleration due to gravity. Okay. Now you have drawn the figure. Let's say this is the liquid column, right? This is the liquid column we have drawn. Okay. Now we'll consider the imaginary the cylinder, that is PQRS, inside the liquid. Right? Just imagine the imaginary liquid which has the the cylindrical surface PQRS. Okay? Just to make sure that our volume things become simple. That's why we are considering the small cylinder, imaginary cylinder inside the liquid, and we'll try to find out the pressure on this surface PQ. Is it correct?
So at surface PQ, so the pressure at P and Q is the same, right?
Yeah. Pressure on the bottom
Okay.
surface. On the PQ, the pressure will be the same. Correct. Got it. So the pressure at the PQ, see basically this is like a cylinder. Okay, just think in terms of Pepsi can bottle.
Okay.
So in this bottom portion of the Pepsi is nothing but the circular area, right? Top portion is also circular area, and top portion is open here, so water is filled from the top. Correct. Now our goal is to find what will the pressure created at the bottom surface of the Pepsi can bottle. Correct. Because Pepsi can is cylindrical, isn't it? Now, how will you find the pressure at the surface PQ? So we know the pressure is nothing but pressure. As per our formula, we've seen that normal pressure is what? Thrust per unit area, isn't it?
Yes, that's right.
Correct, no? Thrust per unit area. Now what is thrust? What is thrust here? Thrust here is nothing but basically the liquid, isn't it? Thrust is basically you don't have any external force coming in the picture. You have only the water contained in the cylinder, isn't it?
Yeah. So is the water in cylinder also, or only
Water in the cylinder?
so the fluid is present in the cylinder also?
Yeah.
Okay.
Fluid is present in the cylinder also, correct. So liquid is present in the cylinder also, right?
Yes, sir.
So whole of the, if you just imagine the whole of the, the liquid, mass will be acting in a downward direction, correct?
Yes, sir, downward.
So whole of the liquid mass is acting in the downward direction, correct now? Whole of the liquid mass will be acting in the downward direction, and that is hitting on the surface PQ, correct?
Yes, sir, the bottom of the can.
Yeah, exactly.
Okay.
So thirst will be given as mg basically. Mg by area, correct?
Yes, sir.
And what is mg? Mg is the anyway acceleration due to gravity, right?
And
What is
yes,
mass
sir.
now? Let's
Okay.
find out mass. Mass is equal to, you remember the density, right? Density is equal to mass by
Sir,
volume.
Sir, but doesn't the water exert force in all directions and not only?
Yeah, it will exert direction, all the direction, correct. Water at the different horizontal level, the water will be exerting the force in all the direction.
Okay.
So plus water is also exerting the force at the bottom of the, if you want to calculate the bottom PQ surface, what is the pressure exerted? So we need to find what is the force exerting on the PQ, right?
Yes, sir. Correct.
The force, there is no external force. The only force existent here is the mass of the water, correct? Which is above the PQ surface, right?
Got it, sir. Till here.
So mass, from here we can just derive mass will be given equal to cross multiply density into volume, correct?
Volume. Yes, sir. Correct.
Density is already given to you for the fluid is rho. Density is given as rho, okay?
Density is rho.
Into what is volume? Volume is area into height.
Area into height. Okay, I got it now. So this
Correct.
is mg. The value of
Yeah.
this is
Now we'll substitute this, what is this? this value, mass in this
Mass
formula,
value.
correct?
In that formula, okay. sir.
Yeah,
And
we'll try to
area
substitute.
gets cancelled.
Exactly. So what you get actually?
H rho G plus.
Yeah, exactly. So what you get is H rho G, right?
Yes, sir.
So that is equal to the pressure. Right? Now the meaning here is, we are saying is that see, it's actually not dependent on the mass also, how much mass it is, right? So we just took the imaginary cylinder just to help you understand that the pressure is not at all dependent on the what kind of surface are you taking it.
Okay. Fine.
See, bottom we took the surface PQ, but it was actually not dependent on that. Anywhere, doesn't matter if you have taken the pressure at this point or this point also, it remained the same, H rho G. Can you see that?
Yes. Sir.
So what is it in the liquid, in the fluids? It doesn't depend on the area where it's exerting it. So at all the surfaces, it just depends on the height only.
So height is the height from the point from where you're calculating the pressure to the top.
Yeah, how deep it is the point, yes.
Yes. Okay.
The more deeper the height,
Higher the pressure.
higher the pressure. Clear?
Clear. Yes, this is clear.
This part is clear now? Fine.
Okay. This
Now write down this derivation so that you understand better. Okay.